Hi, Chris Kuzmal here. We now have written the three helper methods that support doing counting sort. So you would think that we could do a counting sort test. Which I'll call full test. I'm not enamored with that name. We'll call it counting sort test. Counting sort test 1. That way you try to anticipate that we're going to have more than one test program so that we don't have to then fill our one test program with too much code. So our counting sort test is going to do virtually the same thing as our integrated test, but it's going to be integrated more because we're going to have our input array, which we can go ahead and have be 3141 for starters. And then we're just going to do the expected is going to be the result of counting sort of AR. And then our code following is going to be identical again to what we've had in all of our tests. And let's see if we can spell counting sort correctly. And just as we have done in the past, oh my goodness, someday I'll figure out how to do indenting correctly in REPL. So our counting sort test now should fail to compile because we haven't implemented the definition for counting sort, and that's our error. Oh, I also have made a mistake on declaring AR and not making it an array. This is the value of checking because, and now our error is the expected error, which is the counting sort itself. Public static an array of integers, counting sort takes an array and it produces an array, a ret val equal to AR, an array of integers of size AR, the same size as AR, and we will return ret val. And we, as always, as frequently we've done before, we forgot our keyword new. Okay, so this should produce a test case failure with, but we don't have it. Can't find simple counting sort still. Oh, it's because I misspelled counting sort again. We'll try that again. Everything's lovely except that actual can't be found. What happened? Well, oh. I created the wrong value here, actual. And of course we have our expected would be our usual 1134. Okay, let's see if now we've fixed everything up. It fixes everything up and we get the error that we were hoping for, of having an array of the correct size but not the correct contents. And now all we need to do is replicate our integrated test. Where is that integrated test? There's an integrated test. So what we want to do is we want to call histogram of the input array AR, and that's going to be an array which gets passed to scan. Okay. And that's going to be an array that gets passed to placement, and placement is going to also need the original array. So it's going to be AR, comma, and then the result of doing the scan of the histogram. And that's going to be what redfal is. And you can imagine we could just return what's on the right-hand side of this equal sign, but I'm hoping it helps the clarity to have done this. Plus, I'm assuming the code is going to work. If the code doesn't work, then we may need to break things apart again to look more carefully. But shockingly, the code does work. And so we see the cool thing here is counting sort now can be described as being a placement of the array according to the scan of the histogram of AR. And even more exciting, we can do what I said before. I feel a twinge of guilt at doing it this way because I feel like it becomes almost inscrutable, but the naming hasn't been terrible, and better yet, the code works. And so our counting sort is condensed down into just these 3 lines, of which really only 1 line is the counting sort, which is sort of a nested set of fairly understandable calls. And so that's your counting sort. You place your array according to the scan of the histogram of the array. And that is it. Now, there is a little bit more work that could be done, and that is our placement is going to be something we would like to be able to do for satellite data. And we'll talk about satellite data and sorting satellite data in future videos. But this does complete what counting sort is as its core